Now in this video we generalize a result in improper integral type 1. Okay, here we discuss the convergence of this integral where p is a number and that number can range from negative infinity to positive infinity, right? For example, p can be a negative number like this, or it can be 0, or it can even be a positive number like this. Okay, it need not to be an integer all the time. It can be an integer, but it is not necessary, right? So p can range from negative infinity to positive infinity, which is a real number. Okay, so we are going to discuss the convergence of this integral in general, right? Now to do that, we separate our problem into 3 categories, which is the case where p is equal to 1 and p is greater than 1 and p is less than 1. Okay, so under each of these 3 categories we try to compute the integral. Now when it comes to p is equal to 1 case, that means now if I name it as I, then our integral becomes, when p is equal to 1, the integral becomes 1 to infinity 1 divided by x dx, right? And in the previous video I proved that this integral will diverge. Okay, so in the previous video I proved that this integral diverge. So we have already obtained the answer for the first category. Now how about p is greater than 1? Also, now don't mix this one up. Here the lower limit is 1, okay, not 0, right? When it is 0, this becomes 0, so the denominator will be 0 and the function is not defined at 0, right? So don't forget that part, right? This integral will start at 1. In all the previous videos also, this integral started at 1 and it is not 0. Okay, right. How about the second category? That is when p is greater than 1. Now even for this one, in the previous video I did an example where we discussed the convergence of 1 divided by x squared. See, here we have considered p to be equal to 2, which is a particular example under p greater than 1. But and there in that video I proved that this integral will converge, but this fact alone does not say anything in general where p is greater than 1. Okay, so this result does not give a good picture for what will happen to our integral when p is greater than 1. This is just a particular example only. Okay, but now we are going to prove that not only for 2, if p is greater than 1, for all p values greater than 1, the integral will converge. So the result for the case where p is equal to 2 is true for all p values greater than 1. And now I am going to prove that fact. So to prove that, we just have to follow our same procedure of calculating the improper integrals. How do we do that? We just visualize our integral as a limit problem and carry out the calculation. So if we follow the computation, then we have the definite integral from 1 to t where t goes to infinity, and by computing the integral, now this 1 divided by x to the power p can be visualized as x to the power negative p, and then by computing the integral we have this answer. Now see, we are in the case where p is greater than 1. Okay, so p will not be equal to 1. See, if p is equal to 1, then the denominator will be 0, and this result will not make any sense. But we have successfully avoided that situation because p is greater than 1. Okay, right. So now when we apply the two limits t and 1 here, the answer will become this one, right? And remember, this is just a number, so we can take it out from the limit notation, and then we are left with the limit of t goes to infinity, t to the power negative p plus 1 minus limit of t goes to infinity 1. And see, here we don't have, now if we consider this as a function, it does not function of t, and it does not contain any t values, right? So no matter what number t goes to, this value will be the same because it is independent of the value of t. So as a result, this will be just equal to 1, and together with this negative sign in front, you will get negative 1. And how about this expression? Now remember, we are in the case where p is greater than 1. Therefore, as a result, negative p plus 1 will be a negative number. Okay, so how do we obtain that? What we can do is, now from this inequality, if you multiply it with negative sign, then the inequality notation will change, and you can add plus 1 to both sides. Okay, negative plus 1, so this becomes 0. Therefore, we can see negative p plus 1 is a negative number. Okay, you can even consider some examples. Now, as we are in p greater than 1 situation, if we just consider a number which is greater than 1, let's take p equals 1.3, then you can see negative p plus 1 is something like negative 1.3 plus 1, which is negative 0.3, okay, which is a negative number, right? And remember, we have a result in limits where if we are considering the limit of t goes to infinity with t to the power k, and if k is positive, then this result limit will be infinity. If k is positive, no matter how small it is, when t goes to a very large number, this whole thing will go to a very large number. And if k is negative, then the limit will go to 0, right? The reason is, if k is negative, we can write it as the reciprocal. Now, say if we consider the same values of p is equal to 1.3, then t to the power negative p plus 1 will be equal to t to the power negative 0.3. So that can be written as 1 over t to the power 0.3. So again, from this first result, now here in this case, the denominator has a positive k value. Therefore, the limit will be infinity, and since it is 1 over infinity, the total result will be equal to 0. Okay, so as a summary, if we have t to the power k, and if t goes to infinity, then if the power is a positive value, the answer will be infinity. The power is a negative value, then the answer will be 0. Okay. Now, in our case, the power is a negative value. So, as a result, this one will go to 0, right? Therefore, we are left with the remaining term, which is negative 1, right? So the answer we have 1 over negative p plus 1 times negative 1, right? So we can write it as 1 divided by 1 minus p. Not 1 minus p, it should be, now here you have a negative term and you have this one, so this is just the same thing, so we can even write it as, by multiplying both numerator and denominator by minus 1, you can write it as p minus 1. See, p is a number which is greater than 1, so this will be positive. Okay, so the total result will be a positive number. Therefore, we can see that the integral has a finite value. In other words, when p is greater than 1, the integral converges. And we showed that when p is equal to 1, the integral diverges, and when p greater than 1, it converges. So how about this case? We should do the same calculation as before. Now when p is less than 1, we will have the same integral, and we compute it in the way of calculating the improper integrals as I described earlier, right? So what will happen is, since this integral is the same thing, we will have to do the same calculation, and then we will come up to this stage, right? That is this one, right? It's the same answer that we got for the previous calculation, right? 1 over p minus p plus 1 times this integral, right? So for that one, we can see, now here we are in the case where p is less than 1. Therefore, this number will be greater than 0, right? Say for example, now if you want to prove it in general, we have p less than 1. Therefore, by multiplying both sides with negative, we have negative p greater than negative 1, and by adding plus 1 to both sides, we have this equals to 0. Therefore, negative p plus 1 will be greater than 0, right? So this is a number which is greater than 0. You can even consider a example. So if p is less than 1, let's consider p is equal to 0.9. Then we have negative p plus 1 will be equal to negative 0.9 plus 1, and that will be equal to 0.1, which is a positive number. Now when you say p less than 1, it can even be a negative number. Okay, so if this is the number line, 1 is somewhere here, so we can consider all the p values which are less than 1. So you can even take a negative number, right? Something like this. Even then, let's say p is equal to negative 10, then again negative p plus 1 will be negative times negative 10 plus 1, and that will be equal to 11, which is a positive number. So if p is less than 1, then definitely the power will be a positive number. Therefore, as a result, we have this situation. We have the power and t goes to infinity, and the power is a positive number, so it goes to infinity. In other words, this value will go to infinity. Hence, this whole thing will go to infinity. Okay, that means our integral when p is less than 1 will diverge, right? So this is the general result that we need to keep in mind. Okay, so this it's better if we remember this one as a theorem, right? Now if we summarize everything that we have done in this video, for this integral the convergence depend on the value of p. When p is greater than 1, the integral converges. Okay, and when p is less than or equal to 1, the integral diverges. And when I say p less than or equal to 1, then it can even take a negative number. Say if we select p is equal to negative 10, then the integral of x1 divided by x to the power of p will become the integral of 1 divided by x to the power negative 10, and that is the integral of x to the power 10. Okay, so this diverges, right, when we consider the integral from 1 to infinity, right? So this result you have to remember, and it will be very useful even in future lessons. Okay, when p is greater than 1, it converges, and if it is less than or equal to 1, it diverges. And in the next video we will discuss about the improper integrals of type